Access to clean and safe water is essential for a healthy life and a fundamental element for the growth and prosperity of entire communities. Other than drinking, cooking and washing, we use water to grow our crops, for manufacturing, for energy production and for recreation. However, still today about 2.1 billion people live without access to clean and safe water. Heavy metals, harmful chemicals, pharmaceuticals, nanoparticles, pathogens, antibiotic-resistant bacteria and genetic material are increasingly being detected in water bodies around the world. In the poorest regions of the planet where water treatment is incomplete or absent, contaminants can bioaccumulate in the food, the soils and in the drinking water. Efficient and affordable water treatments capable of removing these types of contaminants from wastewater and raw water are therefore urgently needed. PANIWATER is one of the joint European-Indian water cooperation projects funded by the European Commission and the Indian Department of Science and Technology under the Horizon 2020 programme. 18 partners from industrial and academic organizations are collaborating to the development of 6 technologies for the removal of contaminants from wastewater and raw water. 3 of these technologies are designed for wastewater treatment and can produce water that is safe to use for irrigation, landscaping and industrial applications. The remaining 3 technologies are for raw water treatment and can produce water that is safe for washing, cooking and drinking. All 6 technologies make use of advanced oxidation processes, which destroy contaminants by using highly reactive radicals obtained from oxygen-based compounds. In PANIWATER, those processes are triggered mostly with energy obtained from renewable sources, such as sunlight. Wastewater discharging from different sources such as public buildings, hospitals, factories and houses goes normally through primary and secondary treatment for removing debris and bulk contaminants. The PANIWATER wastewater technologies function as tertiary treatment to be used at the point of entry. The solar photolytic plant triggers the oxidation processes by exposing the wastewater to sunlight and consequently ultraviolet radiation. One plant will be capable of treating up to 2,000 litres of water per day. The photoelectrochemical system triggers the oxidation processes by generating an electrical bias through a specifically designed system of electrodes. It can treat up to 100 litres of water per day. The multifunctional reactor integrates automatic mixing and dosage, lamellar filtration and oxidation processes to treat up to 50,000 litres of water per day. After tertiary treatment, the water is safe for landscaping, industrial applications and irrigation. After usage, municipal water goes back to wastewater treatment, while runoff from crops can make it into the water table and is added into the raw water pool. Raw water is generally not safe for drinking, especially if coming from unsafe sources such as ponds, rivers and unprotected wells, and requires treatment. There are 3 PANIWATER technologies set to do that. The EOD system combines electrocoagulation, oxidation and chlorine disinfection to produce 2,000 litres of drinking water per day. The FAU system combines filtration, adsorption and oxidation by exposure to ultraviolet LED light to produce up to 300 litres of water per hour. Finally, transparent jerry cans made of materials suitable to maximize inactivation of pathogens by simple exposure to sunlight can be used as an affordable solution for household water treatment and safe storage. After treatment, the water is safe to be used and distributed for washing, drinking and cooking in communities and individual households. Altogether, PANIWATER provides an integrated approach for water treatment at point of entry level and can make water safer to use in a variety of urban, peri-urban and rural settings, including in resource-poor regions. The technologies are being tested in water-stressed peri-urban and rural areas in India with the support of the local communities and through participation of expert social scientists. The output technologies are intended to be low-cost, power-efficient and simple to operate. Their successful dissemination can contribute to strengthening the local economy and improving public health in low-income communities in India. The United Nations recognizes access to safe and clean water as a human right. PANIWATER is a step in transforming this idea into a reality for everybody.